Hello friends, in today's question, a long conveyor belt moves with a constant velocity of 8 meter per second. Two blocks A and B of mass 2 kg are placed gently on the belt with B on A. Initial velocity of both blocks is 0. Coefficient of friction between A and belt is 0.1. There is no friction between A and B. The length of A is given as 4 meter. So we have to find out these three things. Find the time when B falls off A. Initially B is on the right end of A. Ignore the dimensions of B. B. Find the velocity of A when B falls off A. In the C part, if the coefficient of friction between the block and belt is 0.4, find the separation between the two blocks when B comes to rest with respect to belt. So this is the figure, two blocks A and B, and this is a belt moving with 8 meter per second towards left, and so we can say that our block A, because of friction between A and the belt, it will be also moving towards the left. So this is block A and this is block B. So in the downward direction, we are going to have MA plus MBG, and in the upward direction there will be a normal. Let us suppose that we call it NA plus B. From here we can find out the maximum value of the friction. We can say FR will be equal to mu N of A plus B, which will be equal to mu MA plus MB into G, and mu is given as 0.1 and the mass of each block is 2, so this will be 4 multiplied by 10. So we get FR is equal to 4 Newton. So because of this force, the block A will be moving towards leftward. So we say, let's suppose the acceleration of block A is A, you can say in leftward. And that will be because of this force FR. So we can say here from here that FR will be equal to mass of A multiplied with its acceleration. It is 4, mass is given as 2, and let us call this actually A. You can say that acceleration of A will be equal to 2 meter per second square. Now we are supposed to find the time when B falls off A. So we can say it is given that B is at the right end of the block A. Block B is at the right end of block A. Therefore, the distance traveled by B before falling out, distance traveled by block B before falling will be equal to the length of A, which is 4 meter. And we can use the equation of the kinematics. We can say S is equal to ut plus half at square. Okay, and this S is given as 4, initial velocity is 0, so this will be half. A is our 2, and this will be our t square. Excuse me, please. So from here we get that time will be equal to 2 seconds. So this is the time when B falls off A. Now we have find the velocity of A when B falls off A. So we can find out that the velocity of A when B falls off, so this will be VA is equal to UA plus AT, and initial velocity is 0, so we can say that VA is equal to A is our 2 and time is also 2. We can say that velocity of A will be equal to 4 meter per second. Now it's given that if the coefficient of friction between block and belt is 0.4, find the separation. Okay. So this is next part. Now suppose this is the belt and we have block A. Now block B has fallen off the block A, so it will be somewhere here, let us suppose. And for block B, and this is our belt. So block B, there will be a force, let us call the force of friction FRB towards leftward, because belt is moving in this direction, and there will be MBG in the downward direction and the normal MB in the upward direction. Okay. So we can say that this is for block B. So we can say the force of friction FRB will be equal to mu B multiplied by NB, and it is mu is given 0.4, NB will be equal to MB into G, so this will be 0.4, mass is 2, and this is our 10. You can say the force of friction FRB will be coming equal to as 8 Newton. Now this force will be making the block B travel toward leftward. So we say let it is moving with direction AB. Okay. Therefore this force will try to move block B leftward with an acceleration of AB. So we can say that FRB is equal to MB into AB, and from here we can find out its acceleration. AB FR is 8, this is 2, and we get acceleration AB is equal to 4 meter per second square. And we can also find out its velocity. Okay. Now it is said that block B should come rest with respect to belt. Okay. So for block B to come with rest with respect to belt, for block B to come at rest with respect to belt, the velocity of block B as well as belt should be same. The velocity of block B should be equal to velocity of belt. So from here we can say that velocity of block B, that is VB, will be equal to 8 meter per second. We get the velocity of B as 8 meter per second. Now let's find out the time for block A. Okay. So we can say for block A, now as the block B A has fallen off the block A, its acceleration will be different. So we can say as the block B has fallen off the block A, therefore so this is A, and now it's, we can say the downward it will MAG, and the normal now it will NA, and the frictional force FR. So we can find out that the force of friction for, you can say FR is equal to mu A into NA, which is equal to mu A is given as 0.1 and NA is MAG. So we get FR, let us call it A, FRA is equal to 0.1 into 2 into 10. So we get FRA is equal to 2 Newton. So this is the value of the friction for block A when block B has fallen off the block. And let us say the acceleration of block A is given as AA. So we get MAA is equal to FRA. It is 2 multiplied by A, and this is 2 Newton. So we get acceleration of A is equal to 1 meter per second square. Now let's find out the time for block A. Okay. Now it is also said after some time the velocity of block A will be same as that of belt. Okay. So let us find out the time at which the velocity of block A will become the same as velocity of belt. Let TA is the time at which velocity of block A is same as velocity of belt. So which basically means that velocity of A will be equal to 8 meter per second. So we can use the equation VA is equal to UA plus acceleration of A and TA. Now initial velocity of block A we have already found out is 4 meter per second. Okay. Initial velocity of block A is 4 meter per second. So from here we can say this is of 8, 4, acceleration is 1, TA. So if we get here TA is equal to 4 seconds. Similarly, let's find out the time for block B when its velocity becomes same as that of belt. Let TB is the time at which velocity of block B is same as the belt. So VB is given as 8 per second. So we can use the equation that VB is equal to UB plus AB TB. And we already found out that this is 8 and its initial velocity is equal to 0 and acceleration is 4 multiplied by TB. So from here we can say that time is equal to 4 seconds. Now if you make the comparison between time of block A and time of block B. Sorry, this is 2. 4 divided by 8 divided by 2. So comparing time of block A and time of block B, we can clearly say that TA is greater than TB. So basically it means that block B will come to rest first in comparison to block A. Block B will come to rest first in comparison to block A. Okay. Therefore, we are going to find out the separation time at TB, which is 2 seconds. Therefore, we find out the separation time at TB, which is 2 seconds. So let us find out the distance. You can say for block A, you can say SA is equal to UA T, here let's say TB plus half AA TB square. So you can say for SA, U initial velocity is our 4, so this comes equal to 4 multiplied by 2 plus half, acceleration is 1 and 2 square. So from here our SA will be equal to 8 and plus 2, that is 10 meters. Similarly for block B, SB is equal to UB TB plus half AB TB square. You can say SB, its initial velocity is 0, so we get directly this as half, and acceleration of AB was 4 and this is 2 square. This comes as SB will be equal to, so this is 2, 4, 8 meters. Okay. So we can find out the separation distance between block B and block A will be equal to SA minus SB, which is equal to 10 minus 8, that is 2 meters. So this completes the question. Thank you.